Hi everyone, let's solve today's daily challenge, that is symmetric tree. So in this question we are given the root of a binary tree and we just need to check whether it is mirror of itself or not. That is, it is symmetric around the center or not. Right. So here see, let's see what the question means. So we are given these two binary trees, right? So I want to check, right, whether these are symmetric or not. Symmetric means are they mirror image of themselves or not, right? So when we have a mirror, right, let's say if I write AB here, right, and if I put a mirror here, then what should happen? What I should be seeing? I should be seeing something like this, right? So these are the mirror images, right? So now in binary tree, so what has basically happened is, so if you see this B has come here, right? So an inversion kind of a thing happens when we take a mirror image, right? So that is what we have to check here. So basically we will start from the first node, right? So here the mirror is being kept here. So we have to check for these two nodes. So first thing what we will check, if they are equal or not. So yes, they are equal, fine. Now we will check their children. So we will check for this particular area, right? Now what should happen? So we have 3 here and 4 here, right? So it should get flipped and we should be seeing 4 first and after that we should see 3, right? So here in this case we can say that this is the symmetric tree. Why? Because if you see, this is the third node and this is the fourth node, right? And they have got flipped here, right? According to just like this, right? They have got flipped here and we have got a 4 here and a 3 here, right? So that means this is a mirror image, right? So this part of the tree, if we keep a mirror here, we will be getting a mirror image and it satisfies all the conditions of the mirror image. So that means we can return true for this particular case. Now if you see for the second case here, right, we will be putting the mirror here. Okay, now this is for the root, we don't have to check, we are putting the mirror here. Now here we will check. All right, this is single node, so yeah, so it satisfies the mirror property. Now if you see this particular node, right, this 3 should have been like this here, then it would have been a mirror image. But you see this 3 is here, right? So these are not mirror images, right? We can say that this particular part is totally equal to this, but that is not what a mirror image is. What we need an inversion of flip, right? So if the flip would have happened, okay, wait, if a flip would have happened, then what would have happened? If the flip was there, the third node should be here, right? It should have been here. So that is why this tree is not symmetric, so we have to return false here, right? So now let's see, I hope you have understood what the question is. Now let's see how we'll be approaching it, right? So while solving such problems, the first thing that we think of is recursion. Can we are these can we divide it into smaller problems and can we solve this question using recursion? So let's see. So what we are trying to do is, for like let's create more nodes here. Let's say it is 5, it is 6, it is 7 and it is 8. Now in the mirror image what should happen? We should see 8 here, we should see 7 here, we should see 6 here and we should see 5 here. So these are mirror images, right? So let's see if we can approach this problem recursively. Now first thing that we will do is we will check for the root, right? So if the root is null or if it has any value, if it is null, then we can simply return true at that point. Why? Because you keep a null root and if you take the mirror image, there is only one node, so we will be getting we will be returning true as an answer. But if there are children, if that particular node exists and if it has children, then what should happen? Then we will be simply recursively calling for the left and for the right. Okay, so we'll be having a function, right? where we'll pass our left and right child of the tree, right? So the first thing that we need to check is if they are null or not, right? So if any of these is null or both of them are null, then we don't have to do anything. We can add then and there. If they are equal, right, that is they both are null, then we can simply return true. Otherwise, if any one of them is not null, so we have to return false. Okay, so up to this point, we have clearly understood. Now what, right? Now what we have to do is we have to, recursively call for their children. So how will we, what calls should we making, right? To check the mirror image. Now see, if you see this particular node, right? So let's call it L and let's call it R. So this is L, right? So this is L of left, this particular node. Wait. This is L of left. What is this? This is L of right. Similarly here, this is R of left and this is R of right. Correct. Now, how are we checking, whether they are mirror images or not? So what values are we comparing? So we are comparing L of left with R of right. See, here we have 3 and here we also have 3. And the other comparison is we are comparing L of right and R of left. So where should we making a recursive call? So we should be, to check whether they are mirror images or not. What should happen is, if we have 3 here, right? If we have 3 here, so what we'll be doing is, in this function, we have left and right nodes. So in this function, what we'll be doing is, we will be passing left of left and right of right. We'll be passing left of left and right of right. Okay, now how this is helpful? See, here you first, from this particular node, you were at this particular node and you compared these two nodes, right? That is L of left and right of right. Now, similarly, if you make a recursive call for these functions, right? These two nodes, right? Then see, we have 5 and 6 here. So what should you be comparing? You should be, now let's say this has become our L and this has become our right, correct? When it will go inside of this function, this is what will happening. This will become L and this will become R. So then again what you are doing? You are comparing L of left with R of right, correct? And you are comparing again L of right with R of left. So yeah, so we can say that, we can divide it into sub problems and we can solve it, right? So this is, this is the approach that we'll be following. So this is how we can recursively solve this question. So what we are doing, let me clear this a little bit. So we are recursively calling for the left and the right child. Okay, so we will call for left and the right child. So if their children exist, then what comparison do we have to do, right? We have to compare L of left with R of right. So we have to make a recursive call to these two nodes and in the next and also to these two nodes, that is L of right and R of left. So this is basically what we'll be doing. So let's see it in code. Okay, so see here, I have made this function is equal, right? So here we have the left node and the right node. So first here we have, here we will be checking if the root is null, then we can simply return true. Otherwise, if the root has value, then we should be checking its children, right? So here we will come, this is the first, so in this function, this is the recursive function here is equal. So here first we will check if this left node and right node, okay, if they are null, right? Then if both of them are null, then we can simply return true, right? Otherwise, if one of them is null and one of them is not null, then we will be returning false, right? Now, okay, so we have done this condition, right? If any of the node is null or both of the nodes are null. Now, if both of the nodes, left node and the right node are not null, then we have to make recursive call for the children's also, right? So what we will do, we will check, first we need to, obviously, if they are not equal, then we cannot, move further. So if they are equal, then we should be, only then we should be making a recursive call. So where should we making the recursive call? So we saw that we will be calling the left node of left and the right node of right. So here we should be making a recursive call, and the next recursive call should be to left node of right and right node of left. So we saw here using these nodes that how it works recursively, right? So this is basically how you have to solve this question. So let's quickly run it. So it's accepted, right? So this is basically what you have to do. So you have to write a recursive function where you will be, taking the left node and the right node. And first you will here just check if both of them are null or any one of them is null, right? So according to that, we can, return true or false. Now, if both the nodes are not null and if they are equal, then we should be making the recursive call to their children to check further, right? So here we are making that recursive call. So we saw that the recursive call we need to make towards the left node of left and the right node of right and left node of right and right node of left. So this will basically tell us that whether a tree is symmetric or not. So this is basically how you have to solve this question.